Okay. Hopefully it'll work this time. If you guys need it, let me know if it stops, because I think if it stops, I might be like gonna have to delete some videos. All right. Well, this is a different app, and it has filled up before, so I don't know. All right, so we'll see what happens. Okay, so solve the log equations, check your solutions. Now, can I just drop, how do you drop a log? Give it a swirly. But right now, I have more than one. Is it possible for me to, how do I drop logs?
Swirly in both?
No, so we can't do that.
Darn it.
Yeah, so you merge them, you condense them, yes. So we can only drop a log if it's a single log. Okay. Sorry. All right. Okay, so we need to condense to a single log. So what property allowed us to add the log?
Probably done this one before.
Product property. Yeah, the product property. We get to multiply x times the x minus 21, which would give us x squared minus 21x in the argument there. Now, how do you drop a log? Swirly. Oh, wait. What's this? Oh, it's a 10. That's called the common log. Very good. Look at.
Did you learn that?
Yeah. Whoops. All right. So it's called the common log. And so now, how do we drop a log? We give it a swirly. So that becomes 10 to the second power equals x squared minus 21x. I know. And previously in a minute? All right. And what is 10 squared? 100. All right. So I'm going to subtract the 100 so that we're set equal to 0. And then what can we do? Double bubble. Did we do this one?
I've seen it somewhere.
Okay. So something like it. Okay. What times what is negative 100? Negative 25 and positive 4, which means x could equal 25 and x could equal.
It can't be that one.
Very good. All right. So it can't be negative 4. Why specifically? Yeah, because when you plug it in place of the x in the original, then we would try to do log of negative 4, which is no solution. And that's something you could plug in your calculator just to see if it even works. So 25 should be fine. Yeah, it does just say error. So we know that that's not possible. All right. Natural log. What is natural log? Log base E. Yeah, log base E. Very good. Good to know.
It's like something like 3. Right?
Yeah, it's not quite 3.
Not quite. That's what it is.
Yeah.
Something like not quite.
All right. So we have natural log of x minus 3 plus the natural log of 5. And again, when there's more than one, we want to condense them if we can. And so we are going to, again, use the product property to write this as a single log. So I'm going to be multiplying my arguments together. What's that going to give me? 5x minus 15. Good. 5 times the x minus 3. All right. Natural log of x plus 17. All right. What is this? One-to-one property. Very good. This is, how do we know this is the one-to-one property? Yeah, they got the logs match. If the logs match, then what must be true?
That's the argument.
All right, then x plus 17 must equal 5x minus 15. All right, and we're gonna, let's see, I'm gonna move the x over, that's 4x's. I'm gonna add the 15, that's 20, 32. And then divide by 4, we get x equals 8. And does that seem okay? Yes. No problems with that one. Okay, raise your hand if you got this. All right, good. No.
No, I don't.
No, I thought you said super. Or I thought you meant super.
Come on.
I won't show you until after the test.
What?
I'm gonna go watch some Indian guy right now.
No, I'm not okay.
I'm gonna show us what to
Nothing. Nothing at all.
She's recording.
Okay.
How was there?
All right. Okay, once again, log base b of x minus 1 plus log base b of 5x plus 2 equals log base b of x.
Yeah.
So combine the ones. Wait, break it over.
Could condense those two and make it 1-1.
Yeah, that's definitely easy. So we can condense.
6x plus
For some reason, I have a feeling this is.
Let me just.
Not that there's anything.
Scott Lehman came around and did a
Hi, I'm Scott Lehman. I'm a fool.
My problem is that as I look at this now, that doesn't seem like what I intended.
I don't
know why.
You literally turn on your.
Okay, no, we're good. Okay. All right. So again, I'm going to condense this. Now, is it always going to be, because we're adding the logs, is it always going to be the product property, or?
No, if one's on top of the other, then.
Okay, so if it was subtraction between the logs, then it'd be a division, a quotient property, right? Yeah. Okay, so we're going to, again, condense to a single logarithm, which means I'm going to multiply x minus 1 times 5x plus 2. What do I have to do to those? Yeah, distribute. That's a big multiply there. All right. And so when I multiply that, I'm going to give you a second to do it. I'm getting 5x squared minus 3x minus 2. Very good. Equals log base b of x. Which property is this?
1-1.
1-to-1 property. Again, because the logs match. So this is the 1-to-1 property. All right, if the logs match, then the arguments must match. And so again, I'm going to move my x over. So we're set equal to 0. 5x squared minus 4x minus 2 equals 0. I can try to double bubble that, but it doesn't work. So, quadratic equation.
Oh, yeah.
X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right.
We're all out of 2.
I started a little high, so that's fine. All right. So the opposite of b would be positive 4 plus or minus the square root of b squared 16 minus 4 times a times c. I like to do those together. So that's negative 10. all over 2 times 5. And then let's see, 4 plus or minus, this becomes 16 plus 40, which is 56. I think 56 is divisible by 4. Yeah. All right, 56 is 14 times 4. So how does that square root simplify? Good. The square root of 4. The square root of 4 is 2. And then radical 14 stays behind. And each term is being divided by 10. So I'm going to split that up and divide each term by 10. That way I reduce properly. 4 over 10 reduces to 2/5 plus or minus
Radical 14.
radical 14 over 5. Awesome. Oh, Kalidokali.
Already then. Like that.
The Simpsons. Do you have any questions for me? Don't you know Oakley Doakley?
I do.
Okay. Okay. Oh, we're not done. I thought we were. Oh, sorry.
You know what?
Okay,
I'm going
here
to
we
have
go.
a
So you have both types of questions today, where we have log equations and these exponential equations. How do I know these are exponential?
So they got an X and the X, or I don't know.
Yeah, that is right.
Oh.
That's exactly what they're called exponential because there's an X in the exponent. Okay. So we know how to solve exponential equations when we can make the bases match. So 3 to the X equals 3 to the 4th. If the bases match, then we know that X equals 4. But can I do that here? No, I can't rewrite those. And so we have to solve a different way, using logs to help us. Right now, my X is way up here in the exponent position, and I cannot solve for X when it's all up there elevated, okay? So what we have to do is we have to do something that allows us to drop that power down. What allows us to drop a power? The power property. The power property. If there's a log in front, then we're allowed to drop our exponents. Do you remember that property? Okay. So what we're going to do then to allow us to drop our exponent is we're going to take a natural log of both sides of the equation. That natural log allows that X to drop down in front and multiply times the natural log of 5 is equal to now the natural log of 12. Now how do I get X by itself? Divide by the natural log of 5. And so we get X equals this craziness here. The natural log of 12 over the natural log of 5 is a wonderful answer. Except we want, yeah. We want to use our calculator. So the natural logs do not cancel out, just so you know, okay? Because there's a whole swirly going on in there. Remember, anytime there's a log, you have to give it a swirly. So there's this whole function operation thing that's happening with natural log of 12 to figure out what power, e to what power gives us the 12. So we actually can just do this on our calculator. So we're going to type in the natural log of 12 divided by the natural log of 5. Oops. And we get a crazy decimal. Yeah, 1 point, what'd they say, round to the nearest hundredth? So 1.54. Okay, so now that kind of makes sense. Because if we think back, what's 5 to the first?
5.
5. And
The long pause is making.
what's 5 to the second?
25.
25. And 12 is
Like,
Between. Yeah, so we definitely got a number between 1 and 2. So that makes sense as a solution. Yeah.
where's natural log?
On the TI on the left,
It's right underneath.
Ellen.
It's like 2 above the log.
Right underneath the log.
It was like,
We're just like dashing on it.
All right. Okay. So, believe it or not, there's an infinite number of ways to solve this question. Because it turns out you don't, you can take a log of any base that you want. Okay? And, but the easiest thing to do is to take a natural log. So that's what I'm going to show you. That's what we're going to do. And every time we'll just solve using natural log. Same idea here. I'm trying to solve for x, but right now he's way up in the exponent. What do I do to drop it down? Natural log of both sides. That natural log allows me to drop it in front. So that whole exponent gets dropped in front times the natural log of e, which turns out to equal the natural log of 6. Let's talk about the natural log of e for a second. The natural log of e. What does natural log really mean? Log base e. What is log base e of e equal to?
1.
1. Very good. Why?
because it gets,
And 1 is e.
if you give it a swirl,
Because if you give it a swirly, it makes perfect sense, right? So what is the natural log of e?
No,
1. The natural log of e equals
so
1.
really x minus 3 equals 6.
No, natural log. So the natural log of e is really 1. And so we have x minus 3 equals the natural log of 6. And then how do we solve for x? Add 3. So we get x equals the natural log of 6 plus 3. Now, do I get to put 6 and 3 together to give me 9? No. Natural log of 6 is, it's a function. It's a whole thing. And again, we can type it into our calculators. Natural log of 6 plus 3 equals
4.79.
good. Approximately. And again, you can plug it back in to the original and check to see if the left and right balance, if you wanted to check your answers. And hint on your test, if you have no idea how to solve it, this is a great test for just taking the answer and plugging it in. See if it works.
And it's multiple choice, right?
Yep.
Awesome. I'll just do that all the time. Thank you.
Oh, D is hard. Okay.
There's one more.
There, yep, let there be more.
Close.
3 to the x minus 6 equals 25. 3 to the x minus 6 equals 25.
Natural log.
6. You gotta add the 6 for
So what we have to do is actually isolate first.
6.
So you need to isolate your base to whatever exponent that you've got first. So you want to clean it up as much as you can. So what do we want to do first? Add 6. So 3 to the x equals 31. Now I can think about dropping my power. What allows me to drop my power? Natural log of both sides. That gives me x times the natural log of 3 equals the natural log of 31. And then how do I solve for x? Divide by the natural log of 3. So we get x equals 3.12 or 3.13?
well, around 15.
Okay, 3.13. All right, good. You guys are fast. All right. I'm operating at pre-cal speed, so
That's very quickly.
my neck hurts. Okay. 3 to the 4x plus 3 equals 4 to the 5x minus 1. Be very careful here. This one is quite hard. Can I do any cleanup like I could here?
No.
No, I can't do any cleanup because it's already b to some power, b to some power. The bases are different, aren't they?
Yeah.
Okay. If they were the same, that would be easy, but they're different. All right. So again, I need to do something to allow my powers to drop because I can't solve when my exponents are way up high. So we take a natural log of both sides. So the natural log, and then that's going to give me my big old giant power, 4x plus 3 times the natural log of, well, 3. I'm going to leave out the x, so let's see there. Equals the exponent, 5x minus 1 times the natural log of 4. What do you want to do?
You want to take the logs gives it, then one side and take the x's and
Well, but then, so right, so I like your thought about we want to get the x's, but right now the x's are trapped inside of parenthesis houses.
What do you do to divide?
So I think we should divide.
We should fix them in their houses.
So
Rip the paper.
if we divide by the natural log of 3 and the natural log of 3, but then I get some crazy number here.
Yeah, but then
Oh, you could multiply it. Oh, interesting. So you're saying we would get a crazy number that we would multiply and distribute? So can I distribute?
That'll be a lot.
I want to, I'm going to go ahead and do it this way because this is a math class. And while, yes, you could get a crazy decimal, then we'd be distributing a crazy irrational decimal. And that would thereby make our problem
less.
really, really inexact. Okay. So in math class, we save any and all rounding to the very last step. So that is what we are going to do. So we're going to distribute the natural log of 3 here. I'm going to write it, I don't know, there's lots of ways you could write it. 4 times x times the natural log of 3. Plus 3 times the natural log of 3. All right. On the right, I can distribute the natural log of 4. So, I don't know, 5 times x times the natural log of 4 seems fine to me. And then minus 1 times the natural log of 4, or just minus the natural log of 4. All right, and so Adrian said we want to get all of our x's together. And if it doesn't have an x, we don't want it. So I want things with x's. Here's an x and here's an x. All those terms need to be on the same side. So I'm going to take this whole term and move it over here. What do I want this 3 natural log 3? No, we don't really need that, guys, so we can move him over there. All right, so 4x natural log of 3 minus 5x natural log of 4 is equal to what?
Negative 3 ln 3 minus 3 ln.
Yeah, negative. Okay, I'm going to write negative natural log of 4 minus 3 natural log of 3. Yeah.
Oh, I have no idea.
Oh. Okay. All right, are you good? Good so far? Yeah. All right. So now we have 2 terms over here. What do they have in common?
X.
X. Can I take it a natural log? No. Remember, natural log of 3 is a number. It's like e to what power gives me 3. So it's like 0.213 or something. I don't know. All right. But we do have a greatest common factor here of x. If I take out that x, what's left behind? 4 natural log of 3 minus 5 natural log of 4. Very good. Equals negative natural log of 4 minus 3 natural log of 3.
I feel like this isn't.
Oh, we're getting there. We're done. We're one step more. How do you get x by itself?
Divide by that thing.
Divide by that whole thing. Yep.
Oh wait, we don't have to like get or are we gonna?
You're going to plug it in your calculator. So we're dividing by the whole 4 natural log of 3 minus 5 natural log of 4. Whole thing goes away, and so we get x isolated. And how do you plug that into your calculator? Lots of parentheses, yes. You can put parentheses around the numerator and parentheses around the denominator and do it all in one step if you're savvy. So, is that my sweet spot there? Okay. So I have negative natural log of 4 minus 3 natural log of 3, close the parentheses, divided by the group. My sweet spot is, okay, there we go. Divided by 4 natural log of 3 minus 5 natural log of 4. Close the parentheses set.
1.5.
1.85 approximately. If
You add one after
your TI adds a parenthesis, doesn't it? Let's see. So parenthesis negative natural log 4. Yeah. So on the TI they add they put in that parenthesis right after the natural log. So you have to close that. All right. Minus 3 natural log 3 divided by 4 natural log 3 minus 5 natural log 4. Double parentheses. Lots of work there. Ladies and gentlemen, the hardest part of this is not putting it in. Using your calculator properly. Yeah. Okay. Okay. Oh, how many of this type?
Yeah.
1 or 2?
Okay, I'm
All right, here you go, ladies and gentlemen. That's it.
Okay, well, what's I just
1.85? Roughly?